So in this class, we shall start with term symbols. এখন দেখো আমরা এই টার্ম কথাটার অর্থটা কি? What is the meaning of this term? Term means energy levels. Term means energy levels. Okay, and how we can give symbols for the energy levels. How we can symbolize these energy levels. Now, if you consider one electron system, Bohr theory তে যদি দেখো one electron systems in Bohr's theory, ঠিক আছে? Now in one electron systems, so you know that যে এই Bohr theory তে এই নিউক্লিয়াস এই পরপর n equal to 1, n equal to 2, 3 পরপর এই orbits গুলো, and if we give the energy levels, we know the energy levels, we can designate the energy levels by using what? By using principal quantum number, n equals 2, n equals 3, and so on. So we can give the name of the term by using only one quantum number, that is the principal quantum number. তার মানে আমরা এই এনার্জি লেভেলস যেগুলো দেখাচ্ছি ফর n equal to 1, এগুলো তোমরা পড়েছো, n equal to 2 and so on. তা সেক্ষেত্রে এই এনার্জি লেভেলস গুলো, they are designated by only one quantum number, that is the principal quantum number. তার মানে this is applicable for one electron systems, অর্থাৎ হাইড্রোজেন বা হাইড্রোজেন লাইক অ্যাটমস। কিন্তু আমাদের তো আর we are not interested only with one electron system. Now the question is, how will you represent the terms by energy levels for multi-electron systems? তার মানে multi-electron অ্যাটমের ক্ষেত্রে আমরা how will you represent the energy levels for multi-electron systems? দেখো, for multi-electron systems, for multi-electron systems, for multi-electron systems, we have to introduce some other quantum numbers. ওকে, মাল্টি ইলেকট্রন সিস্টেমের ক্ষেত্রে যেমন ধরো আমাদের একটা কোয়ান্টাম নাম্বার, যেমন ইউ নো দ্যাট দি কোয়ান্টাম নাম্বারস অলরেডি এল আমাদের জানা আছে, দিস ইজ নোন অ্যাজ দি orbital angular momentum quantum number. You know this already, orbital angular momentum quantum number, orbital angular momentum quantum number. M, this is the magnetic quantum number, magnetic quantum number. And there is another quantum number, you know that this is the spin angular momentum quantum number, বা আমরা স্পিন বলে থাকি, spin angular momentum quantum number, spin angular momentum quantum number. Okay, spin angular momentum quantum number. Now, how to designate the term symbols? Now, see, for multi-electron systems, there is a shortcut method which is more important at your level. Say, for any configuration, suppose if I ask you what is the term symbol representing carbon. If you look at this configuration, 1s2, 2s2, 2p2. Okay, now from the configuration itself, we will be able to represent the ground state term symbol. We are more interested right now in ground state term symbols. That means ground state term symbol means only the ground state. Okay, we are interested in ground state term symbols, determination of ground state term symbol. Just a minute. Now, how to determine? That means we are only interested right now in finding out the lowest energy level, ground state. How to write down the symbol of the ground state? Now for that, uh, we have to follow certain rules. That is the Hund's rule of ground state term. Now, before that, let me introduce some other quantum numbers. For example, capital L. This is the total orbital angular momentum quantum number. Total orbital angular momentum quantum number. Okay, this is the total orbital angular momentum quantum number, and it can be found out. I'm not going into the details, just I'm telling you, it can be found out by vectorial addition of the individual orbital angular momentum quantum number. For example, if you look at P2 systems, okay, so there are two electrons. Now you know that for P, the value of L is equal to what? 1. That means the orbital angular momentum quantum number for this electron is 1, and for this one is also 1. There are two p electrons. Now this capital L can be found out by vectorial addition of these individual orbital angular momentum quantum numbers. That means they are found out by addition vectorial addition of small l for the individual electrons. Now, we are not going into the addition right now in this class. Okay, in this lecture. We will introduce it in the next lecture, but that will not be included in your semester 1. So, anyway, so this is how we find out the value of capital L, which is the total orbital angular momentum quantum number. And also, there is another quantum number, capital S, যেটাকে আমরা বলি total spin. So this is the total spin angular momentum quantum number. So this is the total spin angular momentum quantum number. So this is the total spin angular momentum quantum number. Total spin angular momentum quantum number. The total orbital angular momentum quantum number. This is the total spin angular momentum quantum number. And this is also found out by vectorial addition of spin. For example, suppose if for this electron it is S1 and this is S2. Now you know the value of S is always half, isn't it? So, so total spin for two electrons, it can be either S1 plus S2 or S1 minus S2. That means either it can be half plus half 1 or half minus half 0. So when we say this is 1, then we know that the spin multiplicity Sm, you know this is twice S plus 1, isn't it? So this is 2 into 1 plus 1. So it is 3. So we say it is triplet. So when the when the spin multiplicity is 3, we say it is a triplet state. And when this is when this is a 0, that means spin multiplicity, this is 2 into spin multiplicity is twice into 0 plus 1. So this is 1, and we say this is a singlet state. Singlet state, right? So this is a singlet state. We say this is a singlet state. Now, uh, before proceeding further, that means we want to find out, first of all, we want to find out the ground state terms. আমরা ground state termটা বার করতে চাইছি। তার জন্য we need to follow Hund's rule of হুনস রুল অফ গ্রাউন্ড স্টেট টার্ম। তাহলে আমাদের হুনস রুলটা ফলো করতে হবে, ঠিক আছে? হুনস রুল অফ গ্রাউন্ড স্টেট টার্ম, তোমরা দুটো হুনস রুল পড়েছো অলরেডি, হুনস রুল অফ স্পিন মাল্টিপ্লিসিটি and Hund's rule of half filled and fully filled configuration, Hund's rule of ground state terms. ঠিক আছে, Hund's rule of ground state terms সেটা কিরকম? Now there are three rules. Number one, the term with the highest spin multiplicity, the term with highest spin multiplicity will be most stable. The term with highest spin multiplicity will be most stable. Okay, that means it will have the least energy. Most stable means least energy. Now suppose if you consider some of these terms, sorry, say for example triplet p, like this triplet p, or say trip we often write, but see usually the terms are, so I must tell you like this, usually the terms they are represented like this: spin multiplicity capital L and capital J, where J is also another quantum number. Okay, now J, this is known as the total angular momentum quantum number. Total angular, this is the total angular momentum. This is the total angular momentum quantum number. So J is known as the total angular momentum quantum number. Now what is, how this J is found out? J is found out by vectorial addition of, this is found out by vectorial addition, vectorial addition of, vectorial addition of capital L and capital S. So it is found out by vectorial addition of capital L and capital S. Okay, so this is found out by vectorial addition of capital L and capital S. So we are showing you. So suppose suppose if I say among a few ground state terms, suppose triplet D1, say 5S0, maybe triplet P3 or triplet P2, but singlet D0 and so on. So the ground state term, that means the term with rather the lowest energy will be this one, because it has the highest spin multiplicity. Okay, since it has the highest spin multiplicity. Now, this is the first rule. Second rule, see if a certain number of terms, if they have the same spin multiplicity, অর্থাৎ spin multiplicity যদি সেম হয় তখন কি হবে? মানে ধরো আমি বলতে চাইছি এরকম যে ধরো তোমাকে বলা হলো এরকম যে ট্রিপলেট P0, ট্রিপলেট D2, ট্রিপলেট S1, ঠিক আছে? যদি সেম স্পিন মাল্টিপ্লিসিটি হয় তখন নেক্সট আমাদের ক্যাপিটাল এল ভ্যালুস গুলো দেখতে হবে। অর্থাৎ এখানে আমরা দেখতে পাচ্ছি ক্যাপিটাল এলটা কি হচ্ছে, যেমন ধরো স্মল এল এর ভ্যালু আমরা এইভাবে দেখি যে স্মল এল আমরা কি বলি 0 1 2 3, তাই তো? এটাকে কি বলে থাকি? এস পি ডি এফ এরকম বলে থাকি। তা ঠিক ক্যাপিটাল এল এর ভ্যালু যদি এরকম হয় 0 1 2 3, তখন এটাকে বলা হয় ক্যাপিটাল এস, ক্যাপিটাল পি, capital D, capital F, and so on. এইটা হচ্ছে ক্যাপিটাল এফ। তাহলে এখানে আমরা যখন P বলছি, P মানে হচ্ছে L equals, the value of L is equal to 1. When we are considering D, in this case, the value of L equals 2. And for S, the value of capital L equals 0. ঠিক আছে? এবারে বলছে যে যেটা the terms they are having the same values of, what? Spin multiplicity. The values of spin multiplicity, these are same. So if the values of spin multiplicity are same, then what has to be done? We have to consider the capital L values. And the one having the highest value of capital L, in this case L equals 2, will be more stable. That means this term will have the highest stability. Okay, the one with this term will have the highest stability. And if you're asked to write down the order of stability, the stability order আমরা কি বলবো বলো, কোনটা স্টেবল সব থেকে বেশি হবে? এখানে আমরা বলতে পারি যে সব থেকে স্টেবল হচ্ছে ট্রিপলেট D2 lesser than, in terms of energy যদি বলি, এনার্জি যদি বলো, এনার্জি বাড়ছে, ইনক্রিজিং। সো ট্রিপলেট, তারপর বলবো ট্রিপলেট P0, তারপর triplet S1. So triplet D2 will have the least energy in terms of energy or highest stability. ঠিক আছে? এখন আমরা কি বললাম, রুলটা কি বললাম? For a given set of terms having same values, মানে for for a given set of terms, with same values of S বা spin multiplicity, the one with highest capital L value, the one with highest capital L value, the one with highest capital L value will be most stable. The one with highest capital L value will be most stable. Okay, the one with highest capital L value will be most stable. Now regarding the third rule, for terms with same values, of S and spin multiplicity and L, for terms with same values of spin multiplicity বা S, যা বলবে যে কোনো একটা, and L, ঠিক আছে, যদি দুটো সেম থাকে, মানে ফর এক্সাম্পল সে ট্রিপলেট D1, triplet D2, triplet D0, for example, like this. ঠিক আছে? দেখো, you see where the spin multiplicity in all these cases, it is 3, and capital L value, this is 2, যেহেতু D হচ্ছে capital D, তাই তো? So for terms with same values of spin multiplicity and S, দেখো এখানে দুটো পোর্শন হচ্ছে। if if the configuration if the configuration if the configuration is less than half filled, less than half filled if the configuration is less than half filled, then the term with minimum j value, then the term with minimum j value, then the term with minimum j value will be more stable, will be more stable. Then the term with minimum j value will be more stable. That means if the configuration is less than half, ঠিক আছে, তার মানে লেস দ্যান হাফ, যেমন ধরো আমরা যদি বলি p2 কিংবা ধরো ফর এক্সাম্পল d4, তখন the term with minimum j value will be more stable. কিন্তু কনফিগারেশন যদি মোর দ্যান হাফ ফিল্ড হয়, if configuration is more than half filled, so if configuration is more than half filled, then the term with maximum j value will be more stable. Then the term with maximum j value will be more stable. For example, suppose if I say d6 or for example p4, okay, then the term with maximum j value will be more stable. So this is the rule. And for half filled configuration, I'm coming to half filled, I'll show you. So by using these rules, we have to find out the ground state terms. Now, এই যে minimum j value বলছি, how will you calculate the minimum j value? J min, this is actually given by capital L minus capital S. That means the total orbital angular momentum quantum number minus total spin angular momentum quantum number. Suppose if you consider this case, you know that capital L for these three, you know that for these three capital L equals what? Capital L equals 2, and spin multiplicity, that means twice S plus 1, this equals what? 3 in all these cases. So S equals 1, isn't it? So in this case J min will be what? 2 minus 1, তার মানে 1 হচ্ছে, and in this case J max, maximum value of J বলছে, J max টা কি হবে? This will be given by L plus S, L plus S, ঠিক আছে? J max টা তুমি যখন বার করবে, this is L plus S, তাহলে L plus S যদি করো, দেখো this is 2 plus 1, 3. So this is the maximum value of J, ঠিক আছে? তাহলে ট্রিপলেট, আমরা আর একটা টার্ম বলতে পারি ট্রিপলেট D3 হতে পারে। দেখো J ইকুয়াল টু এইটা হচ্ছে। So it's like this. Now let us come to a real example. দেখো এগুলো দেখিয়ে it appears to be a bit confusing at your level, but once I show you a real example, things will be much more clear. Suppose let us start with carbon. Okay, আমরা কার্বন দিয়ে স্টার্ট করেছিলাম। Let us start with carbon and find out the. So what we will try to do is to find out the ground state terms. See, for carbon, we know we want to find out the ground state term. We know it is 1s2, 2s2, and 2p2. 1s2, 2s2, 2p2. Therefore, if you write down the outer configurations, outer shell configuration rather, দেখো এই 2s আর 2p আছে, দেখো this is 2s আর এটা 2p, so 2s2 and 2p2. In general, we are interested mainly with the outer orbital configuration, where you can find that দেখো এখানে আমরা যদি টোটালটাও দেখি, দেখো এখানে the values of m, you know that for s orbital, for s orbital আমরা জানি যে L equals 0, m equals 0. For p orbitals, you know that the value of L is equal to 1, and m can have values minus, you know this already, minus 1, 0, plus 1. So these are the values of magnetic quantum number. তাহলে আমরা দেখতে পাচ্ছি যে এখানে দেখো in this case the values of m, if we write down the values of m here, this is 0, this is minus 1, say for example 0 plus 1. তুমি উল্টোটাও লিখতে পারো, মানে you can give plus 1 here also, any of them like this. Usually you will understand later on that when m is equal to 0, it is the pz orbital. m যখন 0 হয়, pz. Anyway, we'll not discuss this right now. So these are the values of m. Now how to calculate the value of capital L? Now capital L, see, this is how you will calculate. This is summation of m. This is summation of m. Capital L, summation of m. That means for each of the electrons, you will find out the values of m. See, for electrons in the s orbitals, 0 plus 0 for the 2s electrons. Then this plus 0 minus 1 for the 2p electrons, isn't it? So the value of capital L, this is equal to 1. I want a mod value nichi so that it becomes positive always. We have to take the mod values. Now when L equals 1, you know that S, P, D, F and so on, these are the, so the values of L for this 0, 1, 2, 3 as already mentioned. So when L equals 1, we will say this is capital P. Okay. Now we want to find out the value of capital S. দেখো capital S টা যে unpaired electron আছে, there are two unpaired electrons. So it is obviously what? Half plus half. There are two electrons with parallel spins. It both can be minus also. যা বলবো, two electrons with parallel spins. So it can be either, since they are of parallel spins, so they should be added. তাহলে আমরা এখানে capital 1 বলছি. So the spin multiplicity, this is given by twice of capital S plus 1 as per definition. So this is what? 2 into 1 plus 1. So this is 3. So we have calculated, we have found out the value of, we know that this ground state term, this is represented by spin multiplicity Lj. So we have calculated the spin multiplicity. We have found out this is what? This is capital L. We have found out capital L. Now we have to find the value of J. So J should correspond to J min because it is less than half filled. So this will be L minus S. So what is the value of L? L is how much? L is 1. দেখো এখানে L এর ভ্যালুটা কি আছে এখানে? L এর ভ্যালুটা এখানে 1 আছে আর S এর ভ্যালুটাও 1, তাই তো? S এর ভ্যালু কিন্তু এটা নয়, this is spin multiplicity. This is a common silly mistake যে S এর ভ্যালুটা spin multiplicity বসিয়ে দিল। Clear? So this is 1 minus 1. So 1 minus 1, 0. So the ground state term, therefore, is triplet spin multiplicity L. What is L? P, and J is 0. So this is the ground state term. For this is the ground state term for carbon. তাহলে কার্বনের গ্রাউন্ড স্টেট টার্মটা আমরা বার করলাম এইভাবে, তাই তো? So this is the ground state term for carbon. Now let us try to find out the ground state term for oxygen. Okay. Say for oxygen, you know it is helium 2s2 2p4. So if you write down the electronic configuration, I mean the box diagram for the outer shell, তাহলে এটা হচ্ছে 2s, এই 2p, তাহলে যেরকম আমরা গ্রাউন্ড স্টেট কনফিগারেশন লিখি, we have to write down the ground state configuration and hence find out the corresponding term. So this is the ground state configuration. This is how we write down the ground state configuration. And then what we will do, we will find out the ground state term associated with it. That means the corresponding symbol representing the energy level of this ground state. তাই তো? তাহলে দেখো, so if you write down the values of m, দেখো এখানে m এর ভ্যালু 0, আমরা এইভাবে লিখছি -1 0 +1 like this. So what is capital L? We know that capital L, this is the summation of m. So 0 plus 0, 0 plus 0 for the 2 electrons in s orbital, -1 for these 2 electrons, -1 and -1 for these 2 electrons. Clear? Both are -1. Then +0 for which electron? This one, this electron, +0, and +1 for the other electron. So what is the value of L? This is 1. দেখো L এর ভ্যালু তো 1 ই আসছে, আর এটা কেটে যাচ্ছে। So L equals 1 means capital P. So what should be the value of capital S? Now capital S has to be equal to, there are two parallel set of electrons. These are paired up already, isn't it? এটার জন্য 0 হচ্ছে, এটার জন্য 0 হচ্ছে। So তুমি পুরোটা দেখিয়ে দিতে পারো। You can show all of them. Say +half, -half, +half, -half for the electrons which are paired. Then +half, you can show it like this. Okay, তার মানে আমরা আসলে এই দুটো ইলেকট্রন, they are actually a parallel spins. So capital S, this will be equal to 1. So spin multiplicity, this equals twice of capital S plus 1. So this equals 2 into 1 plus 1 3, তাই তো? So what should be the value of capital J? This will be capital L plus S, because J should correspond to J max, since it is more than half filled. So this equals capital L টা হচ্ছে কত? 1 plus S. So this is, so the ground state term, it should be what? Spin multiplicity কত? 3 triplet. L হচ্ছে, L এর ভ্যালু কি হচ্ছে? এটা P, and J value is 2. So this should be the expected ground state term. So let us consider another example, say for nitrogen. Say for nitrogen, you know it's helium 2s2, helium 2s2, 2p3. This is for nitrogen. So once again, if you write down the configuration, box diagram টা লিখছি আমরা for the outer shell. So this is 2s, 2p. So 2s2, 2p3. দেখো এটা হচ্ছে হাফ ফিল্ড। তাহলে হাফ ফিল্ড কনফিগারেশন আছে। Now let us write down the value of m here. m এর ভ্যালু দেখো এখানে 0, m এর যে ভ্যালুস গুলো এটার জন্য 0, -1, 0, +1, তাই তো? তাহলে আমরা ক্যাপিটাল L টা বার করি। This is the summation of m. দেখো এখানে electrons in the s orbital 0 plus 0, electrons in p orbital প্রথমটা হচ্ছে -1, তারপরটা হচ্ছে 0, তারপরটা হচ্ছে +1. So the value of L is 0. দেখো when L equals 0, we know it is capital S. L যদি 0 হয় তখন আমরা কি বলে থাকি? This is capital S. তাই তো? Now what should be the value of capital S? মানে total spin rather. এইখানে capital S টা, obviously this is not total spin. This is the value of what? Capital S, this is the value of L. Rather, this is the symbol representing the value of L. So capital S, that is the total spin. So this will be equal to what? For the two electrons in s orbital, একটা হচ্ছে plus half, একটা minus half. For the electrons in p orbitals, plus half, plus half, plus half. So this is what? 3/2. ঠিক আছে তো? 3/2 হচ্ছে। So what is the spin multiplicity? Spin multiplicity হচ্ছে twice of s plus 1. So this equals what? 2 into 3/2 plus 1. So it is 4. Quartet state. তাহলে 4 মানে it is the quartet state. তাই তো? Now what should be the value of J? So if you want to find out the value of J, দেখো J can have values. We know that it can have values L plus S or L minus S. Maximum value আর minimum value টা বলছি আমরা, দেখো তাই না? This is the maximum value. তাহলে L plus S যখন হচ্ছে, L এর ভ্যালু কি আছে? 0 প্লাস কি 3/2, আর এল মাইনাস এস যখন বলছি 0 minus 3/2, so it's basically the same. This is 3/2. So you can consider the maximum value or the minimum value, because you know that the value of L is 0. So remember, whenever the configuration is half filled, whenever the configuration is half filled, the value of capital L will be 0. So if the value of capital L is 0, okay, then the value of J will be equal to S, because L is 0. So the value of J will be equal to S. তাহলে J min and J max, they will have the same value. So the only value that is permissible here in the ground state term, rather, that is 3/2. তাহলে আমরা এই গ্রাউন্ড স্টেট টার্মটা তাহলে আমরা কি বলবো বলো? স্পিন মাল্টিপ্লিসিটি এইটা, তাই তো? সো it is quartet. স্পিন মাল্টিপ্লিসিটি এইটা হচ্ছে এল এর ভ্যালু কি হচ্ছে এইটা এস 3/2, ঠিক আছে তো? মানে টোটাল স্পিনটা তাহলে আমরা এখানে 3টে প্যারালাল সেট অফ ইলেকট্রন যদি থাকে, টোটাল স্পিনটা আমরা এখানে 4 পাচ্ছি, 3টে প্যারালাল সেট অফ ইলেকট্রনস, বিকজ তাহলে কি হয়ে যাচ্ছে 3/2 twice into 3/2 plus 1 হয়ে যাচ্ছে. So it's like this. Next, let us consider another example. Suppose if you look at, say, for the transition metals, say, for example, chromium, say chromium 3 plus, for example. Okay, so chromium 3 plus আমরা জানি chromium হচ্ছে argon. আচ্ছা, let us start with chromium 3 plus ই করি. Argon, we know it is 3d5 4s1, if you remember. The chromium 3 plus যদি হয়, chromium 3 plus হলে argon 3d3, argon 3d3, তাই তো? 4s এ আর কিছু নেই. তাহলে দেখো আউটার শেলেতে, দেখো for transition metals, the outer shell we have to consider 4s as well as 3d. মানে আউটার যে কনফিগারেশন 4s এবং 3d, you know that the energies of 4s and 3d, they are quite close. So that is why we need to consider both 4s and 3d. কিন্তু এখানে তো 4s থেকে দেখো ইলেকট্রন is lost. So naturally we will consider only the 3d. So you know that the m values for this is -2, -1, 0, +1, +2. So these are the values of m. এটা তোমার জানা আছে. And the configuration, look, we are writing down the ground state configuration, so it should be like this. This is the ground state configuration. So if you want to find out the value of capital L, look, capital L, this is summation of m, isn't it? So it should be what? দেখো এইটা আর এটা -2, -1, +0. So this is 3. আমরা জানি SPDF, এখানে আমাদের L values হচ্ছে 0, 1, 2, 3. That means it is capital F. Capital F হচ্ছে আমাদের, তাই তো? So it will be capital F. Okay. Now, if you want to find out the value of total spin, the total spin, দেখো 3টে unpaired electron আছে, so 3 into half. 3 into, so this is 3 by 2. This is the total spin. What is the spin multiplicity? This is 2 into capital S plus 1. So this equals 2 into 3 by 2 plus 1. So this is what? 4. তাই তো? Spin multiplicity 4 হচ্ছে। So what is the value of um, J? J should correspond to J min because it is less than half filled. So this is L minus S. What is L? L এর value দেখো 3. So this is 3 minus what? S এর value 3 by 2. So it is 3 minus 3 by 2. So 3 minus 3 by 2. So this is 3 by 2. তাহলে what is the ground state term? Spin multiplicity কত? 4 F, তাই তো? দেখো এইটা হচ্ছে F L and J value is 3 by 2. So this is how we can find out the ground state term for chromium 3 plus. Now if you're asked to find out the ground state term for, say for example, maybe Fe3 plus, আচ্ছা Fe2 plus, Fe2 plus. So you know that the configuration for iron is argon, argon 3d6 4s2. So Fe2 is, these two electrons will be lost. These two electrons will be lost. So this is argon, argon 3d, argon 3d6. So this is -2, -1, 0, +1, +2. These are the values of M. So দেখো 6 মানে এই ইলেকট্রনস গুলো ধরো আমরা এইভাবে যদি দেখাই 1 2 3 4 5. Normally this is the ground state electronic configuration. Right? So this is the ground state electronic configuration. So if you want to find out the values of L, capital L এর ভ্যালুটা বার করো। ক্যাপিটাল L এর ভ্যালু হচ্ছে দেখো তুমি এখানে করো নিজে -2 -2 এই এখানে দুটো ইলেকট্রনের জন্য, তার পাশে -1 +0 +1 +2, তাই তো? So the value of L is 2, 012 SPD. Now what is the value of capital S? There are 4 unpaired electrons, so 4 into half. So capital S is 2. So what is the value of capital J? Now this is more than half filled. So J should correspond to J max. So this is L plus S. So what is L plus S? দেখো L এর ভ্যালু 2, S এর ভ্যালু 2. So this is 4. Now what is the spin multiplicity? This is 2 into 2 twice S plus 1. So it is 5. তাহলে আমাদের গ্রাউন্ড স্টেট টার্ম কি হচ্ছে? স্পিন মাল্টিপ্লিসিটি L L J. The spin multiplicity কি হচ্ছে? 5. quintet state. L কি হচ্ছে? L হচ্ছে ক্যাপিটাল D আর J হচ্ছে 4. So this is how we can find out the ground state term for Fe2 plus. Let us consider another example. For example, say if you look at chromium. if you write down the electronic configuration of chromium itself, and if you want to find out the ground state term. Okay, so chromium, you know that the configuration, already you know this, argon, 3d5, 4s1. So this is the electronic configuration of chromium, তাই তো? তাহলে আমরা, if you want to write down the outer electronic configuration, as I mentioned, you have to include both the D, I mean 3D and 4s. So these are the, this is 3D and you have to consider 4s. You cannot omit 4s because outer orbital configuration is 3D and 4s, because both these orbitals, they are very close in energy and both are involved in bond formation. Now, if you write down the electronic configuration D5S1, so it's like this, 3D5, দেখো এই 3D5 হচ্ছে and 4s1. So the values of m, -2, -1, 0, +1, +2, and this is 0, তাই তো? So if you want to find out the value of capital L, see the value of capital L is, দেখো এখানে -2, -2, sorry, -2, -1 for the d orbital, -2, -1, +0, +1, +2, +0 for the electron in the 4s orbital. So the value of L, this is what? 0. L0 মানে হচ্ছে capital S. Now what is the value of total spin? দেখো total spin হচ্ছে 6. There are 6 unpaired electrons. 5টা present in 5d and 1 in 4s. So total spin will be 6 into half 3. So what should be the value of J? J, দেখো, L plus S equivalent to L minus S. Why? Because the configuration is half filled and capital L is 0. So এটা তুমি L plus S করো, L minus S করো, the value will be same. So J will be equal to 3. And what is the spin multiplicity? Spin multiplicity is spin multiplicity, দেখো, this is twice of capital S plus 1. So this is twice into 3 plus 1. So it is 7. So the ground state term is 7. দেখো এটা হচ্ছে S, L টা হচ্ছে S, and this is 3. The J value is 3. Okay. So this, I'll continue with this lecture in the next class.